Hello, I'm Ahmad Mirabi. In this video, I would like to share a short sample of my teaching with you. Okay, I want to talk about logarithm today. So let's teach a bit about logarithm, what is the definition of logarithm, and domain of logarithmic function. A logarithm is defined like this. If logarithm of x with base b is y, then we can say b to y power is equal to x. So we can say x is equal to b to the power of y. How this is read in mathematics? This can be read like this. This can be read like a log b of x, or a logarithm of x with base b, Okay, so let's apply it in some examples. For example, logarithm of 25 with base 5 is equal to 2. Why? Because we can write 25 as the second power of 2, like this. So 5 to the second power is 25, therefore log 5 of 25 is 2. And therefore log 3 of 27 is 3, because 27 can be written as 3 to the third power. If we consider negative powers, log 10 of 1/10 is -1, exactly just like above. 0.1 is equal to 1/10, or 10 to the -1. So this is definition of logarithm. So if we consider base to the power of the answer is the argument of logarithm, then we can remind the definition of logarithm and we can go forward with lots of logarithm problems. So let me make some more examples and then introduce the domain of logarithmic function. So for example, logarithm of 116 when base is 2 is -4, or we can write logarithm of 10 with base 10 is 1, or we can say logarithm of 1 with base 10 is 0. And of course logarithm of 1 with every basis is 0, because every number to the 0 power is 1. Of course here a shouldn't be 0. So logarithm of 1 with every basis is 0, because a to the 0 power is 1. Okay, so can we define, let me first tell you that if the basis is not written, the base is 10. So log of 10 is 1. If the base is not written, or if the basis is not written, it is 10. So it is called, so when base is 10, we can skip writing it. We can skip writing the base. And it is called the common logarithm. It is called common logarithm. So we can skip writing the base when it is 10. So we can say logarithm of 100 is 2, because 10 to the second power is 100, and the logarithm of 1000 is 3, and the logarithm of 10 to the 4 is 4. As you see, very large numbers are transformed into smaller numbers. So logarithmic scale is a way of showing very large numbers or very small numbers. For example, logarithm of 10 to the negative 9 is negative 9. So very small numbers and very large numbers are transformed to a small scale, which is called logarithm scale. Okay, so now we introduced the common logarithm here, that when the base is 10, we don't need to write it down. We can skip writing it down. But when the base is 2, 3, or other numbers, we must write the base. Okay, now consider this logarithm. Logarithm of negative 1 when base is 2. In this logarithm, we are finding for a number that 2 to that power is negative 1. Of course, there is no number. That's why it is undefined. So, in the function of logarithm of x with base 10, let me skip the base, or logarithm of x with base 2, whatever, when the base is an acceptable number, let me write a, x must be positive. X must be positive. So domain of this function is positive real numbers. Now, what about the bases? The bases should be positive again, because if the base is negative, for example, consider this, a negative 1 or negative 3. The base can be, the base cannot be negative and cannot be 1. Let me say it cannot be 1 first. The base cannot be 1. Consider this logarithm. Log base 1 of 2. What is this? The answer is 1 to which power is 2. Of course, the 1 to every power is 1. Therefore, again, this is undefined. We have no answer to this. So we understand that the base cannot be 1. The base cannot be 1. Now, we know that the base of a logarithm comes as a base of a power number. For example, let me write it like this. Logarithm of x with base a is b if and only if x is equal to a to the b power. Now, what if the power is 3 seconds and the base is negative 1, or the base is negative 4, whatever? Negative 1 to the 2 means negative 1 to the third power and then the square roots. And we know that you cannot take a square root of a negative number, so it is undefined. So that's why you know the base cannot be a negative number. And in power numbers and exponential numbers, again, with the same reason, the base cannot be negative. So another restriction of logarithmic function is base cannot be negative. Base must be positive. So these are restrictions of a logarithmic function. And if we want to, for example, so let me complete my explanation here about the base. So here is a logarithm of x with base a, and the reverse of this function, the exact meaning of this function is x equals a to the y power, and x equals a to the y. You know, this is a exponential function with base a, and because y, we have lots of values for y. We usually consider all real values for y, a cannot be negative. Therefore, in an exponential number, a cannot be negative. The base cannot be negative. Here again, base cannot be negative. So now, in an exponential number, in a logarithmic function like this, ux, vx, if you want to find the domain of this function, u, which is the argument, should be positive. V, which is the base, should be positive, and V, which is the base, cannot be 1, based on what I told you above. This is how we find the domain of a logarithm function. So domain of logarithmic function. Okay. After these topics, we can introduce let me solve one or two more example and finish this sample teaching. As an example, we want to know what is the value of logarithm of, for example, 32 with base 4. Okay, we know that we should search for powers of 4 which is equal 32. So 32 equals 4 to which power? We know that 4 to the first power is 4, 4 to the second power is 16, and 4 to the third power is 64. So what is this unknown number here, that 4 to that power is 32? If we take it as unknown, for example m, we can write both sides as a power of 2. So this is 2 to the 5th power, and the right hand side we have 2 to the second power to the m power. And as a rule of exponents, we can multiply the exponents here. So 2 to the 5th power is equal to 2 to the 2m. Let me rewrite the left hand side correctly. So 2 to the 5th power is equal to 2 to the 2m. Now we have two exponential numbers. The bases are the same, so the powers must be the same. Therefore, 2m must be equal to 5 and m is equal to 5 second, or 2.5. The answer is 2.5. The answer of this logarithm is 2.5. Okay, we can introduce a graph of logarithmic function next, and then say a logarithmic function is a reverse of exponential function, and then solve some examples of drawing the graph of logarithmic function and considering the translation and expansion or contraction, those topics. And then we can introduce the some properties of logarithm, for example, quotient rule, power rule, or power property of logarithm, or product property of logarithm, or change base property of logarithm. And after that we can solve logarithmic equations. These are some topics that come after this teaching. Okay, it's enough for here. Bye bye for now.